need to start or we need to set timer 1 and this timer 1 in mode 2, that is 8-bit auto reload mode, and we can transmit the data. Okay. So here these two bits SM0 and SM1, these two bits, when these two bits are 0, it is default 8-bit serial communication mode, okay, or UART mode, where the oscillator frequency is fixed. Okay. Then if these two bits are 0, 1, then it is variable baud rate selection can be done by using 0 and 1 bit. Okay, that is mode 1. Then 1 0 and 1 1. These are mode 2 and mode 3. So in which 1 0 is fixed oscillator frequency or fixed variable with the oscillator frequency divided by 64 or divided by 32, and 1 1 is where we can use the variable frequency or variable baud rate. Okay. So these two mode 2 and mode 3 are used when the multiprocessor communication is used. Okay. And for normal communication, here either the mode 0 and mode 1 is used, in which mode 0 is used when it is synchronous communication. That means there will be the clock frequency of both the transmitter and receiver should be the same. Okay. But if it is not same, or if we want to make your communication, in that case we need to use mode 1. Okay. Then after that we have seen if suppose I want to transmit the character from microcontroller to the other device. Okay, let's assume the character is A. So A is the character which we want to transmit through the microcontroller, okay, to the other peripheral devices. Okay. So for this, what we need to do? We need to first set T mode. This T mode should be in timer 1 auto reload mode. So here the bits are D7 bit is get, so it will be 0. Okay, timer mode, so C oblique T bar will be 0, and then we need to use mode 2 for 8-bit auto reload, so the bits are 1 0, and for timer 0 all the bits are 0 0. So this data will be 20. Okay. The next is we need to set the count for TH1 because it is 8-bit auto reload mode. So that count is used to fix the baud rate of the serial communication. So here to fix the baud rate, what we need to do? We need to by default the oscillator frequency divided by 12, which is used for timer. Then whatever the frequency is available, that frequency, let's assume F, that will again get divided by 32. Okay. So we are getting something to 8800 count. Okay, or to 8800 hertz. When we divide it by 3, we are getting the baud rate of 9600. So 28800, when it is divided by 3, we are getting the baud rate of 9600. Just I need to calculate it. So 28800 divided by 3. Right. So we are getting 9600 as the baud rate. Okay. Now the same 28800, when we divide by 6, we are getting the baud rate of 4800. So 28800 divided by 6, 4800. So here, according to by dividing the frequency whatever we are getting, when we divide it by 3, we are getting the actual baud rate, okay, which is required. Okay. So here, these 3 or these 6, which we need to subtract from the maximum count FF, which can be stored into the TH1. So FF minus 3 plus 1, we are getting the count as FD. Okay. Or here we can write it as minus 3 in terms of decimal. So if now here in this program, if suppose we want to transfer character A with the baud rate of 9600, we need to set the count accordingly. Okay. So here it will be T mod is equal to 20H. Then for TH1, the count will be 0 FD H. Now the third one is SCON. Okay. Now here, if we want to transmit the data in mode one, the two bits of the SCON, upper two bits are SM0 and SM1. So these bits are 0, 1. Then SM2 bit we need to keep it as 0. Then receive enable, either you can keep it as 0 or 1. If you want to receive the data, that bit should be 1. Okay, but if you are not receiving the data, we are transmitting the data, so you can keep it as 0. Okay. Then the TB8 and RB8, these two bits are not used for SCON, or we need to keep make it as 0, 0, and we need to clear transmit interrupt and receive interrupt. Okay. So here this count will be 40. Okay. So we need to set 20H into TMOD, 0 FD or FD into TH1 and SCON with 40H. Okay. So that will be the first place. So here we will start the program org0000H. After that, move tmod, hash 20H. And move th1, hash 0 FDH. Sorry, FDH. And then move SCON, hash 40H. That will be the initiation of all the special function register. Okay. After that, here we need to start the timer for transmitting the data. Okay. So to start the timer, what we need to do? We need to set the TR1 bit, okay, of the SCON register. Okay. Then whatever the data which we need to transfer, that data should be available into the S buffer register. So here we will write move S buffer. There is the special function register which is used for serial communication. So here we need to give the data as A. Now see here, though we are writing a character A here, when the data is getting transmitted, it transmits the ASCII value of this character A. Okay. So here, whatever the data which we want to transfer, that data should be available into the S buffer register. So we have taken it into the S buffer register, so that it will get shifted to for the transmission. Okay. Then here, this data will get transmitted unless and until transmit interrupt bit will get not is clear. Okay. So when TR is set or transmit interrupt is set, what does it mean? The data has been completely transferred from S buffer to the other peripheral. Okay. So we need to wait unless and until this TI bit is set. Okay. So we need to wait unless and until this TI is set. Okay. So we will wait here. When the TI is set, we need to clear this TI so that the next data will get transferred. Okay. And after that, if you want to repeat the process, we will repeat it with Hello, am I audible? Hello. Okay. So here we need to clear transmit interrupt, and if you want to repeat the process here, what we'll do? We'll just let's jump up, and where we need to give this up to this location before move sbuff comma hash. Now here why we are writing or keeping it loop and only up to sbuff, because scon is by default it is set, and when tr1 is set, then as it is 8-bit auto reload mode, here by default when the overflow occurs, the previous data whatever the value which needs to be loaded into the th1, that will automatically get reloaded. So here only we need to keep the loop up to the move sbuff comma hash a. So here when we run the program, then we can observe that the value or the character a will directly getting transferred to the external peripherals. Okay, so we will just check it out in this program on kill. Serial transfer .s. We need to save the file with .s. End statement is missing. So we'll write end. Okay, now see here, when we run the program, the data of this character A will get continuously get transferred, but we need to check it. Okay, so here in view, you need to open the serial window UART1, 2, or 3. Okay, so by default, I am taking UART1. Okay, so this will be the window. Okay. And when we run the program, continuously observe that all the character A is getting transferred. Okay, everyone got it? Now, if I want to stop this transmission, or for only I want to make a single transmission here, this or we need not require to keep it in the loop. Okay. One more thing here, this S buffer, it is it can hold 8-bit data. Okay, so only we need to give one character or one data into the S buffer register. But assume that we have a string of characters and we want to transfer that data. Then here we need to make some changes into the program. Okay. So in this program, here we need to define one memory location. I'm writing it with move dptr comma hash x. X will be some address location for this dptr. Okay. And this S buffer here, I need to write it as X. Okay. Now, here, whatever the data which is getting transferred into this S buffer, that will get access from the memory location of the data pointer, and that will get transferred to the S buffer. Okay. So here, what we'll do? We will move the contents into the accumulator. So before that, we will clear the accumulator, because here we need to use implied addressing mode. So here we will clear accumulator, and after that we need to move the contents into the accumulator from the memory location which is pointed by data pointer in the implied addressing mode, because this implied addressing mode is used for accessing the lookup table. Okay, so here the instruction is move CA at the rate a plus dptr. A plus dptr. Okay. And then we will move the contents of accumulator into the SP. Okay. Now this is the process. But here we have defined the data pointer with the database X. So we need to create the database also. So here what we will do, we will write X db colon X in double inverted comma. If I am writing HS PIT Kolhapur comma 0, and after that end. Okay. So only by making these changes here, the data is available into one memory location X. Okay. And that data is first, or every character of this database or string is getting accessed into the accumulator, and then it will transfer to the S buffer register. Okay. So here to write the database or to write the string, what we need to do, we write db colon X colon in double inverted comma KIT Kolhapur comma 0, or some, what we can say, a character string. Okay, only that much of changes we need to do. Okay. So we will check it out now. Oh, too much errors. Oh. What was the problem? Here comma right. Oh. Okay, so here we need to do, after transferring the data, we need to increment dptr. Right. So here, what we have done the mistake. So I have written database, this word and this X at other locations. Okay. So here we build the program, and now we will run the program. Now see here, when we run this program, okay, after transferring the complete data KIT Kolhapur, it gets vanished because again it will get repeated and the next data will be 0000 onwards. So here only we are getting KIT Kolhapur for one time, and after that it is getting vanished. Okay, because our UART is showing the next data or next character, that's a 000. So see here KIT Kolhapur and it. So if we want to stop it, here what we need to do, we need to make some again changes here. We need to stop after complete transfer of this KIT Kolhapur, or sequentially we need to transfer this data again and again. Okay. So here we need to write this data pointer, or we need to initiate this data pointer again after control E, after clearing the accumulator. So here what we will get, continuously the data will get transferred. Okay, so here to transfer the data serially, what we need to do, we need to set the TMOD register, we need to set TH1 register, and we need to set SCON register. Okay, and after that the data transfer will take place. If you want to transfer only one character, directly we can take that value into the SBUF and we can transfer it. But if you want to transfer a string, we need to load the string in or lookup table into the memory location, and the memory location address will get accessed with implied addressing mode, and the data we need to take into the accumulator, and from accumulator the data will get transferred sorry, to the SBUF. Okay, so this is the process for writing the program for serial communication. Okay, everyone got it? Now in the same program, here we have transmitted the data, but if we want to receive the data, here what we need to do, we need to make the changes into the SCON special function register. So here we need to load it with 50H, because here the count will be the SM0, SM1, these two bits are 10, SM2 bit is kept 0, receive enable we need to make it as 1 to enable the reception. Okay, and after that the next T bit R bit will be 00 and TI RI will be 00. So here the count will be 50. That 50 we need to transfer or we need to load that count into the SCON register. So here SCON register will become 50. Okay, and when we want to receive the data, that data will get available into the SBUF register. So if the data is available in the SBUF register, that data we can either transfer into the memory location or to the port. So here we need to make, I have already written the program here for a reception, sorry, in key. Okay. So here what we need to do, is it visible for everyone? I will take it into the Word window. So here by default, we need to set the TMOD with 20H, TH1 with -3, or you can write it here as 0 FDH, okay, and SCON with 50H. And we have started the timer. So the same process as that of the serial transmission, here in this serial reception, we need to do the same process. So we will start the timer, we will clear RI so that when the interrupt will get generated, that will set RI. Okay. And we'll wait unless and until this RI bit is set. Okay. Once the bit is set, whatever the count which is available into the SBUF register, that will get transferred into the accumulator. And after that, you can transfer the data to the port or to the memory location. So here I have taken one memory location which is pointed by pointer R0, and that memory location is 30H. Okay. So at this memory location, the data will get transferred. Okay. After that, I am just incremented the R0 and then SGM count. Okay. So the same program is written here. I will just add this program. Okay, is it visible to everyone? See here, only we have started the timer and we are waiting unless and until this RI bit is set. Okay, so once the RI bit is set, here what we need to do, the count which is available into the S buffer, that count is taken into the accumulator and transferred either to the port or to the memory location. Okay. So just we will debug the program. Now see here in the same UART window, we have observed the data during the transmission. Now during the reception, we need to put the data into this UART window, and when we are writing some data into the UART window, here the data will get available into this 30th location or memory location, or the same will be observed in this port. So just I am running the program. Now I am writing the character A into this UART window. So when I write A, see here the count which is available into the 30H location is 41. Okay, this is the ASCII code for character A. Now the same is available on port also. Okay. Now in this UART window I am writing B. See here at 31 location the count is 42. Similarly, at this port, we have got the 42. Okay. If I am typing C, see here 43, then for D 44, then E 45. If I write Q, it is 51. If I write Z, it is 5A. So whatever the characters I am writing here, according to that, the value will get transferred to the port location or to the memory location. Now here, why this memory is increasing? Because I have initiated the memory location with 30H, and indirectly I am transferring the contents of accumulator to that particular memory location, and after that the memory location is increased. Okay. So for transmitting the data should be available into the S buffer register, and during the reception of data, the data which is received at S buffer register, that will get transferred into the accumulator. Okay, everyone got it? कोणाच्या काही शंका आहेत का? Okay, now for baud rate, here we can change this baud rate also. So in spite of writing 0 FD, here we have written -3. So here if I write -6, okay, then the baud rate will be 4800. If we write 12, then the baud rate will be 2400. Okay, so according to that also we can change the baud rate into this programming. Now, if suppose we want to increase the baud rate or double the baud rate, here one more bit is required, that is available into the PCON register. So the D7th bit of this PCON register is called SMOD bit. Okay. Now, when this SMOD bit is 0, then baud rate will be same as that of provided. Okay. But if this bit is 1, then the baud rate will get doubled. Okay. So here, if we want to increase the baud rate, here this SMOD bit is made as 1. Okay. So here, if suppose the baud rate is 9600, then SMOD is 0. Then when the SMOD is 1, in that case here the baud rate will become 9600 multiplied by 2, so it will be 19200. So that will be the baud rate for in spite of 96000, the next baud rate will be 19200. So the baud rate will get double when this S mod bit is of the Picon racer is 1. So the Picon racer is also required for serial communication to increase the baud rate. So only that bit is important from the Picon racer. It is also called as power control register. So from this register, the D7 bit is required. Remaining bits are just ignored bits, and after that the D1 and D0, these bits are for saving the power or to keep the controller into the idle mode and so on. Okay, so here in the same program, here if we want to increase the baud rate, here only we need to write one instruction, that is set B Picon, which race it is, S mod bit. Okay, so set B S mod, only that instruction is written here. Okay, and then the program is written. Okay. Got it? So this is all about this serial communication. In the next lecture, we will see the programming for serial communication in embedded C. Okay. Are there any queries?